And,
Yes, Professor, could you go over number 15 and 4.3?
okay,
You show me
what
how.
number is it?
Hard, page 215.
Sorry, the,
Show me how you approach it.
sorry, the twisted nose just looking for 3.
I got one, because I think we did 2 and 4. So I took one problem out of 4. And when you do those problems, you know, you can't use a compass, but the only thing is you can say construction, then I know that you constructed it, right? So which number are we doing?
15 on 4.3, please.
Okay. Any isosceles triangle, the median drawn from the vertex angle is the perpendicular bisector of the opposite side. Okay. So, 215, 15. So what we have, we got an isosceles triangle. So
Two congruent sides, two congruent angles.
So what we have is, I'm going to say those two sides constitute the isosceles congruent sides. And then it says a median drawn from the vertex angle is perpendicular bisector to base. So what you have is you have a median. A median is something that cuts the opposite side into 2 parts. So what you have is these two. That constitutes the median.
And the angle up top will also be equal.
No, that median don't do that. Median cuts the opposite side in 2 parts.
That's it.
That's it. Yeah. Okay. See, what you have to do is that it's perpendicular bisector of the base and of the opposite side. Okay. Because you can have a, you know, non-isosceles triangle. You can draw a median from any of the vertices, and it won't bisect the angle from which it comes.
But it will always bisect the base.
Yeah, median means that it's bisecting the base it's going towards. Okay. So, what we want to prove that, and then I'm going to put D, that BD is perpendicular bisector of AC. Okay, because it's a median, it's a bisector, but we have to show that it's perpendicular.
Are we going by?
Yeah, Vincent asked for this problem. Okay, so the first thing is that AB is congruent, because it's a proof, CD, and that's given. I'm going to show those 2 triangles are congruent. That's 2, then AD is congruent to CD. I think I wrote this wrong. This is should be a B. It's given that it's isosceles. Okay. And this is given median. This is given isosceles. Then what we can do is we can go BD is congruent to BD.
This is like the school of format.
And that's reflexive. And then we could say that the triangle ADB is congruent to the triangle CDB. And that's side, 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 right? And then we can say angle ADB is congruent to angle CDB, and that's corresponding parts of congruent triangles. Angle ADB plus angle, or I guess I'll just do it this way. CDB straight angle. And that's the definition. Therefore, angle ADB equals angle CDB equals 90 degrees, and BD is perpendicular bisector of base of AC. Something along that lines would be, I think, show it. There could be a modification that you would take a different tack on, 5 through 7, but it has to kind of show that kind of a thing. Does that answer your question? Mm-hmm. Okay. Now in these present problems, because you can't show that, the use of a compass, when you state I want you to state a justification for what you're doing. And that statement of justification, when you say construction, it means that, you've either used a straight angle or compass. That's how you're going to do it. And then we have to justify the fact that it does occur. Now I did 2 and 4. And then 6 on page 225. It says draw a line segment AC and label point B between points A and C. Use your compass and straight edge to bisect the angle ABC. So a line segment, and that line segment has a beginning and end point, AC. And then they just say any point So I'm just gonna take any point, not midpoint, not any point, point B. Between A and C. And then it says, use your compass and straight edge to bisect angle ABC. Well, if you look back at
What number is that, number 6?
what's that?
What number is that? Number what?
Say that again.
What number? What number?
Oh, this is 6. So if you look at construction 6, and that says construct a perpendicular bisector of a line segment. So what you can do is you can put your point of your compass at B and mark off this so that these 2 points, these 2 lines are equal. So I'm gonna establish point D and point E. So I'm gonna go for my proof of my justification. I'm gonna say I have done BD congruent to BE, and that's construct. So when you say that, I know that you have used your tools, which is the compass, to establish that. And now you go back and if you look at construction 6, perpendicular bisector, what you'll do is you go strike an arc there, putting the point at E, putting the point at D, strike an arc, and then you go down here and you strike an arc here and here. Now that doesn't look like it, but that construction should create a perpendicular bisector of DE. So then F, G, F, G, perpendicular bisector of BD, BE, DE, and this would be construction 6. And now that direction says draw a line segment AC, label B between the points, use your compass and straight edge to bisect angle ABC. So that's a perpendicular bisector at B. Now what I can do is I can say then DF is congruent to EF, and that's construction. I guess I probably wouldn't even have to do that. What I could actually say without doing threes, I could say angle A, B, F equals angle CBF equals 90 degrees. And that's, you know, definition of perpendicular. And then what you have done is DF bisects, because they want just bisected, right? Bisects angle A, B, C by definition. I probably wouldn't even have to say that ABF and CBF are 90 degrees. I just have to say they're congruent.
Right. Wouldn't you have to prove the two smaller triangles first?
No, because this line right here
Mm-hmm.
is a perpendicular to this line right here.
Mm-hmm.
Therefore, those two angles are 90 degrees. They're equal. And then this line, because this angle equals that angle, both being 90, then that bisects the angle, that straight angle, ABC. Because ABC is a straight angle.
What's that last line, sir? DF? Is that right? Don't you mean GF?
BF.
Number 5.
BF. This was B. I meant to say B.
Yeah, okay.
Sorry.
But you would also accept FG.
Yeah, FB, FG, but
Okay.
On number 4, why you say ABF instead of DFB?
because it said it's talking about the line AC, and that, you know, not DE, but they're in the directions. It says draw a line segment AC, label B between the points A and C. Use your compass and straight edge to bisect ABC. So ABF equals CBF, although it's 90 degrees to the DE, but we want 90 degrees to the line AC, not ED, according to what it's telling us in the problem. And this is just a justification. Not a proof, so to speak. It's like telling me how and why do you think it does what you're told to try and do. Different than a proof.
Not by much.
Yeah. Okay.
Can I see the last part? Thanks.
So 8 says draw a line segment ED, use a compass and straight edge to divide it into 4 congruent segments. So 8. Draw PQ. This is P. This is Q. Compass and straight edge to divide it into 4 congruent segments. So if you look at your possible constructions, the construction 6, if you use it 3 times, you can get that divided into line segments. The construct a perpendicular bisector of a segment. The perpendicular is not necessary, but the bisector would be. So if what you would do is you would take your compass, make it longer than half the length of that, and strike an arc up here, strike an arc down there, and then go to the other side with the same length, strike an arc here, strike an arc here, and then you would connect those lines.
2 equal pieces.
Yeah, and then what you would say is that we call it AB. So AB is a perpendicular bisector of PQ and that's construction 6. And then let's see, that says that PC is equal to QC by definition of bisector. Now, if you take the length PC and you have a compass and strike an arc that's longer than halfway, you would get an arc up here and an arc up here using construction 6 again, and then connect those two. And then, let's see.
Professor, you mean equal or congruent on number 2?
I guess you could call them congruent or call them equal, but the problem is saying draw a line segment using compass straight edge to divide into 4. I guess congruent parts. I should use congruence.
Just checking.
I thought they said equal, but it's congruent parts. All right. Now then, this one. And we got A, B, C, D, E, and F.
Where do you put your point to mark BD? Is it between B and C?
Say that what?
To mark AD at that point, where did you put your compass?
Well, you put your compass, you put, for that green perpendicular,
Yeah.
you put your compass point there and there.
Okay.
That's what that construction 6 says to do. So DE perpendicular bisector of PC. And that's construction 6. Then you would say PF is congruent to FC. And that's definition of bisector. Now, we're going to go and do the same thing with CD. So we'll put our compass, our sharp point here and here, strike an arc longer than halfway. Make that. And then so we have to letter this D, E, F, G. We're going to G, H, I. Okay, G, I, perpendicular bisector of CQ, construction sets. Then you'd have CH is congruent with QH, and that's a definition of bisector. Now, it's, you know, we've actually shown this one and this one are congruent. This one and this one are congruent. Then the PC and QC are congruent. So it's all of those being equal. How are you going to make a statement? And I guess therefore P, Q, and what is the thing asking for?
4 equal pieces.
Use the compass and straight edge to divide into 4 congruent segments. The only thing that bothers me a little bit at this point is to showing that the two divided parts PF and FC, which are congruent to each other, are actually equal to CH and HQ. There is no definitive statement to say that, other than you could say in general, being it's a construction problem, by observation, this occurs. To prove it definitively, you know, you'd have to go back and talk about that PC is congruent to CQ, you know, that these two divide those into half, the other two divide them into half, therefore but that's pretty lengthy on a construction problem.
Why can't you say PF is equal to FC, CH to HQ?
And if you said that, you'd have to say by observation. You couldn't say it definitively. You haven't proven it definitively. But with a construction problem, you could probably get by with saying by observation these occur. Because if you prove it definitively, then you got to go back and say that PC and CQ are congruent, and that, you know, these two are halves of PC and these two are halves, and make some kind of a real rigorous type of proof. But with a construction problem, I think that, you know, to me it would be obvious is if you said by observation, you know, FCH, you know, divided, or else PF, you know. And that's what I'm gonna do, is I'm just gonna say by observation. I'm gonna say PF congruent to FC, which is congruent to CH, which is congruent to HQ, and I'm going to say observation. It's not a definitive proof by any means. You can just see that you got congruent segments that you've divided into half, and therefore each one of those halves have to be congruent. And you actually, yeah, and that would be divided into 4 congruent parts, so you've shown it. But in order, this is the point I'm trying to make here, is when you do a construction problem, you can't just draw a bunch of lines, because I got no idea what you're doing. You would have to tell me, this is construction, and make it somehow so that I can see what you've done. And then that it actually, the construction problem is a geometric, you know, proof problem. I mean,
Loosely.
yeah. Okay. So I'll give you the quiz. Yeah. 26. I mean, by no means would this kind of a thing ever